all right? So probability is really chance. It's the chance that something will happen, okay? So if I have a dice has a 1 on it, a die, actually, singular, right? It has 3 on it. It has 4. Of course, they're not numbers, they're dots, right? 5 and a 6. And I ask you, what is the chance that I roll this dice and I come up with the number 2? Okay? How many 2s are there on the dice? 1. That's what goes in the numerator. What are the total number of choices that can be rolled on the dice? And there are 6. Right? So the chance of me rolling a 2 would be 1/6. Now what if I ask you, what is the chance of me rolling a number greater than 3? Well, how many numbers are greater than 3 goes in your numerator? That's 3. So, and how many total we have is 6, or it's 1/2. We can ask, what is the probability if we have 2 dice of rolling a sum of 7? And you'd have to figure out how many dice, what would be the combinations in the dice that you would roll that would get 7. So with probability, a lot of times it's, we use dice and we use coins, all right? So if I had a coin, a penny, we know one side is heads, one side is tails, right? If I flip the coin, what is the probability that I would get heads? Well, I'd ask myself, in the numerator, it's how many of those outcomes could I have? And there's only one head, right, on a penny. And how many, what are my choices? Heads and tails, there are 2 choices, okay? All right, so let's look at 116.6. In 116.6, we do have 2 dice, all right? And it asks on page 472, what is the probability of A getting a sum of 7? So we want the sum to be 7. So I ask myself, what could I roll on the dice such that the sum would be 7? Well, I could do 1 and 6, right? I could do 2 and 5. I could do 3 and 4. If I rolled 4 on this dice, I could get 3 on this one. If I rolled 5 on this dice, I could get 2 on that one. If I rolled 6 here, I could get 1. So our permutations, here are our individual arrangements, right? 1, 2, 3, 4, 5, 6 out of. And now, what would my denominator be? My denominator would be 6 out of, what are my total possibilities? It's 6 times 6, or 36, because there's 6 on each dice. And that equals, we simplify it, 1/6. Okay? B says, what is the probability of getting a sum greater than 8? So the sum has to be greater than 8. Can I roll 1 and anything to get greater than 8? No. 2? No, because the highest other dice would be a 6, and that equals 8. That's not greater than 8. 3. Not, okay, let's start with 6 and go down. 3 and 6 would definitely be greater than 8. 3 and 5 equals 8, so there's no more with 3. See, I'm just moving up on my dice. Does that make sense? So 4 plus 3, no. 4, no. 4 plus 5 is 9, yes. And 4 and 6 is 10, okay? Now what if I go to 5? 5 and 3 is 8, so I can roll 5 and 4, I can roll 5 and 5, I can roll 5 and 6. Now we go to the 6. 6 I can roll, not 2 because that's 8, 3, I can do 6 with 4, 6 with 5, and 6 with 6. So how many permutations do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 out of 36, which can be simplified, correct? Both of them are divisible by 2, so that would be 5 and 18ths. So 5/18 would be the probability that I get a sum greater than 8. And then let's look at 116.7. The last part is about independent events. So if I flip a coin 3 times, each event is independent of the other. Because I'm reflipping the same coin. It's sequential events that do not affect each other. So I can flip it once and get a heads or tails. I can flip it the second time, get heads or tails. So when you look at independent events, they're unrelated, and one doesn't affect the other, then you multiply the probability of each independent event. Look at 116.7. A fair coin is tossed 3 times. What is the probability that it comes up heads every time? So we're going to do 3 times. We want heads this time, we want heads the second flip, and we want heads the third flip. Independent events, we multiply to get the probability. Okay? Well, the first time the probability that I get heads is 1 out of 2. There's only 1 heads. There's 2 options, heads or tails. Right? Second time, the same. Third time, the same. So the probability that I get heads every time is 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. It's 1/8. And let's look at 116.8. 116.8, page 474. Now we have a fair coin tossed 4 times. And it comes up heads each time. Listen at this. What is the probability that it will come up heads on the next toss? We only want to know on the next toss. What is the probability that it comes up? We don't care what happened the first 4 times. Okay? The probability that it comes up heads is simply 1/2 because they're unrelated independent events. Okay? All right. See you guys Tuesday.